Hello friends, welcome to Mechanical Engineering Solutions. In this video, we will discuss about viscosity. Yes, the most important property of fluid. Simply, viscosity can be defined as the resistance offered by a fluid to the flow. And it is caused by the intermolecular friction between the fluid molecules. When we consider the fluid is flowing over a surface, at the interface of solid surface and fluid layer, the no-slip condition is present. That is, the relative velocity between the fluid layer and the solid surface will be zero. When we moving to the above fluid layers, the relative motion will be possible. And the below layer is kept stationary and the above layer is moving, makes a velocity gradient between the layers. So we can conclude that the viscosity or dynamic viscosity is the friction between two adjacent layers. The velocity gradient also defined as the tangent drawn to the velocity profile with respect to the vertical length. That is du by dy equal to tan theta. Now we can come into the next topic, Newton's law of viscosity. It is defined as the shear stress between two adjacent layers will be directly proportional to the velocity gradient between that layer. That is tau directly proportional to du by dy and tau equal to mu into du by dy, where mu is the coefficient of viscosity or dynamic viscosity, which is one of the important property of fluid. And we have to remember one more thing. The velocity gradient also equal to the rate of shear strain. So we can also define the shear stress between two adjacent layers is directly proportional to rate of shear strain. Dynamic viscosity have the units Newton second per meter square or Pascal second or kilogram per meter second in SI system, and also poise or diameter per centimeter square in CGS system. And 1 poise is equal to 1 by 10 Newton second per meter square, or we can say 10 poise is equal to 1 Newton second per meter square. And the dimension of dynamic viscosity is m L raised to minus 1 T raised to minus 1. Along with this, we can study one more quantity, kinematic viscosity, which is defined as the ratio of dynamic viscosity to the density of fluid. That is nu equal to mu divided by rho. Kinematic viscosity have the units meter square per second in SI system and stoke in CGS system. And 1 stoke is equal to 10 raised to minus 4 meter square per second. I'll give you some example. We know that density of water is around 1000 kg per meter cube and the air is 1.17 kg per meter cube. When coming to dynamic viscosity, water have the dynamic viscosity 1.005 into 10 raised to minus 3 Pascal second, and air have the dynamic viscosity 1.81 into 10 raised to minus 5 Pascal second at 20 degrees Celsius. When we come into kinematic viscosity, water have a kinematic viscosity of 1 into 10 raised to minus 6 meter square per second, and air have the kinematic viscosity of 15 into 10 raised to minus 6 meter square per second. That is, the dynamic viscosity of water is 50 to 55 times larger than dynamic viscosity of air at 20 degrees Celsius. When coming to kinematic viscosity, the kinematic viscosity of air is 50 times larger than the kinematic viscosity of water. Now we can go to the factors affecting viscosity, that is temperature. In liquids, the viscosity is due to the cohesive force between adjacent molecules. When the temperature increases, intermolecular spacing also increases. As a result, the cohesive force also decreases. This results in reduction in viscosity. So we can conclude that in liquids, as the temperature increases, the viscosity decreases. In gases, the intermolecular spacing already high, so cohesive forces are negligible. But in gases, the viscosity is due to the intermolecular momentum exchange between adjacent layers. When the temperature rises, the intermolecular activity also increases. This will result the increase in viscosity. So we can conclude that in gases, as the temperature increases, viscosity also increases. When temperature increases, the dynamic viscosity of gases also increases, whereas the kinematic viscosity increases much faster. But we have to remember one thing, the viscosity of liquids always higher than the viscosity of gases. This is all about viscosity. When we come into the fluids, there are two types of fluid, is the Newtonian fluid and non-Newtonian fluid. Newtonian fluids are the fluids which obeys the Newton's law of viscosity. And of course, the non-Newtonian fluids which doesn't obey the Newton's law of viscosity. These all things we discussed above is about Newtonian fluids, and we will study the non-Newtonian fluids in next class. This topic have the significant importance in all exams, so be careful and study well. As I told earlier, please do subscribe and share this channel to those who need it and enjoy the magic of mechanical engineering. Thank you.